A secant is a line, a ray, or a segment that intersects a circle in 2 points. If it was just a segment, sometimes we call that a chord. Have you got notes out? It's already on there for you, yes? Okay. A tangent line is a line, a segment, or a ray that's perpendicular to the radius of a circle. And the point that the line intersects the circle is called the point of tangency. Okay, we are going to write on our picture. Tangent in this context means something different than opposite over adjacent when we did right triangles. This means a line that's perpendicular, that makes a 90-degree angle with our radius or diameter. And point B is the point of tangency. It's where it touches the circle. The measure of an angle formed by a tangent and a chord or a secant line is half the measure of its intercepted arc. So, for example, if angle C down here was 30 degrees, what do you think the arc would have been? Careful, the angle is half. 60. So the arc's double. The angle is the smaller piece, okay? Same scenario here. What if this arc was 220 degrees? What would angle C need to be? 110, okay? Yes, yes. Notice that the vertex of that angle, and this kind of leads into what she was talking about, the vertex is on the circle, you just take half. Just like our inscribed angles that we were doing, you just take half. It all has to do about where the vertex is in relation to the circle. Okay? So we have the vertex on the circle. We can have the vertex on the inside of our circle. If the vertex is on the inside of our circle, this looks like our warm-up question today, then we're going to add the two arcs and then take half. So I'm going to put some numbers on here so that if you look at this at a glance, hopefully it'll, you'll see the relationship a little bit quicker. Excuse me. So if the red one was 50 and the blue was 30, and we wanted to find the measure of angle 1, we would take 1/2 of 50, the bigger arc, plus the smaller arc, 30. So 1/2 of 80, 40 degrees. So angle 1 in this one would be 40. Just finding angle 1. Yeah. There'll be some kind of number. Mm-hmm. or the vertex could be on the outside. All three of these cases, they're a little bit different, but all the vertexes are on the outside. Therefore, all the formulas are the same. This time, we're going to subtract the arcs and then take half. So if we wanted to use some numbers, so you can kind of get a sense of what's happening here. Let me raise it up. If we were to let's say this is 60 degrees, and this arc in blue was 20, and we want to find angle 1, which is on the outside of our circle, the vertex of our angle. The measure of angle 1 would equal 1/2 the biggest arc, which happens to be the red one here, so 60, minus 20, and therefore angle 1 would be 1/2 of 40, 20 degrees. And that would be the same for the other two cases. So I'd like for you to take like 2 minutes with your partner, and I want you to summarize the relationship between the vertex of your angle that you're looking for and the formula. When do you do what? So discuss it. Let's try to summarize what we've just talked about. Okay? Or sheet. So it was a different color for some reason. Okay? And we're going to have the problem say that SR line, SR, is a tangent line with the point of tangency at Q. And QR is going to be, we're going to say is 3, and PQ is 4. So here's our problem. We want to find PR. If SR, line SR is a tangent line, and Q is a point of tangency, what measure is angle Q? What is angle Q? Look at your definition of tangent. What does it mean to be a tangent line? Or a point of tangency? Well, that's true. It's half the measure of an R now. We don't have any arcs, though. 90. Okay. Tangency means that this is a 90-degree angle. QR is 3, and PQ is 4. Now, these are sides. I don't have any measures of arcs. I don't really have any angles except for the 90. Okay? So if we're looking for this other segment, we have a right triangle. How do you find the third side of a right triangle? Good. Pythagorean theorem. Excellent. So we're going to have 4 squared plus 3 squared equals c squared. I'm letting this be c because it's the hypotenuse across from the 90. Take the square root of both sides, so C would be 5. So PR would be 5 units long. right, let's look at the next example. All right, this time we got arcs and angles. The vertex is on the inside, so you can look at your half sheet or formulas that we have. Do we add them? Do we take half? Do we subtract? Add them and then take half. Okay. So x degrees is going to be 1/2 of 46 plus 90. (136), so x would then be half of 136. 68. So x is 68 degrees. Questions that you have so far? What can I answer for you? What can we get a classmate to answer for you? All right, we got one more. Okay, shoot.
When like the angle is on the outside from the side, like it said like on the other side, how would you find you do the same thing? Like on a circle, like the 46 is right there.
This time we're not really looking for the angle, we're looking for an arc, so we're going to have to work backwards. So I'm going to write down what you told me that we were going to have to do. The angle, I'm going to write it in words. The angle is equal to 1/2 the biggest arc minus the smaller arc. Okay? In words. So our angle, we know what our angle is, so I'm going to substitute 20 degrees equals 1/2. Which arc do you think is bigger, the 95 degrees or the z? 95, okay. So we're going to say 95 minus z. And we're going to have to solve for z. So you can distribute the 1/2 through, that's fine, but you're going to have fractions. So that I won't have any fractions, I'm going to take care of the 1/2 first. I'm going to multiply both sides of my equation by 2. 2 times 1/2 make 1, so I just have 95 minus z is equal to 40. If you'd rather distribute the 1/2 through, go for it. But you will have, you know, like a fraction or possibly a decimal if you want to do it that way. Subtract 95. So that's negative 55. Divide by negative 1 because we want to know what positive z equals. So arc Z is going to be 55 degrees.